Okay, sorry, I saw that the video was getting blurry. So the centric load is P over A, and this load is a tensile load, right? So it's positive. So slide 14, P over A is pi r squared. That's pi times, we have the diameter is 0.5, so r is 0.25 inches. Area is a circle, so pi r squared, and force is given 160 pounds. Okay, so from slide 14, you get So you get 160 pounds divided by pi times 0.25 squared. So that's going to equal positive 815 psi. Now, okay, let's do, so this whole thing is 815 psi. Now let's do this stress from the moment. Okay. Okay, so so the equation for moment, the stress for a moment is stress equals to mc over I. Okay, I have it right here. So moment, we already found, is 104 pound-inch. C is the radius, so 0.25. C is from the centroid to the top or bottom. And we need I. I for a circle is 1/4 pi r to the 4th. Okay, so slide 15, we have I equals 1/4 pi r to the 4th, and r is 0.25. So I is 1/4 times pi times 0.25 to the 4th. So we get 3.068 times 10 to negative 3 inch to the 4th. Okay, so stress max for moment equals to 104 pounds-inch times the radius 0.25 inch over 3.068 times 10 to negative 3 inch to the 4th. That equals to 8,475 psi. So let's draw the stress distribution for moment. So that's 8,475 psi. Okay. The moment is a clockwise moment. So the right part of the member is going to be in compression, so negative. And the left part of the member is going to be positive. It's going to be in tension. So this is negative 8,475 psi. Okay, notice that, again, the axes. So here, the stress axis is parallel to the load. So the load is upwards, so the stress axis is vertical. Okay, and the distance axis, y, is perpendicular to the stress axis. Okay, so the stress axis is parallel to the load. Okay. Okay, so now we've drawn the centric load plus the moment, and that's how we're gonna get the eccentric load at the cross section. So what do? We just add the numbers. Okay, so let's turn to slide 16. This number here is going to be 815 plus 8,475. That's going to be 9,260 psi. How about on the rightmost? It's going to be 815 minus 8,475. So that's going to be negative 7,660 psi. Okay, so now you have your answer. So at this section, the straight portion of the section of the link, the maximum tension, the tensile stress, is 9,260 psi. Maximum compressive stress is 7,660 psi. Okay, so that's slide 16. Now the question asks you the distance between the centroidal and neutral axis of the section. How do we find the distance between the neutral axis and the centroidal axis? How do we find this distance right here? Okay, so how are we going to find that? Slide 17. We are going to set this stress equal to 0. Okay, slide 17. So again, the neutral axis is when stress equal to 0. So we're going to set 0 equals to this whole equation here. Okay, so for the problem, the vertical axis is stress x. The distance is the horizontal axis. So when stress is 0, it's here. When stress equals 0. So we're going to make stress equal to 0. Okay. So let's turn to slide 18. Okay, so let's find y. We want to find the distance between the origin to the neutral axis. So we're going to find the distance y. The origin to neutral axis. So we're going to find this y right here. What is y? Okay, let's do algebra. We're going to add the my over I equals to PA. Okay, we're going to multiply the I, divide the m. Okay, so this is how we find y. Okay, so just plug in numbers. 160 pound times 3.068 times 10 to the negative third inch to the fourth over area. Area is 0.1963 inch squared times moment. £104 pound inch. Okay, so that's how we're gonna find y. Y is 0.024 inch. Okay, so the distance between the origin to the neutral axis, that y distance, is gonna be 0.024 inch. Okay, let's turn to slide 19. Notice sometimes there will not be a neutral axis. So when you add the eccentric load and the stress from the moment, you get different stress distributions. Right? These are different eccentric loading depending on how the numbers come out. So the top, there is no neutral axis, right? It never hits zero. Stress never gets to zero. It's all tensile stress right here. Here, stress does get to zero right here. What is this telling us? This is telling us that the eccentric loading is causing tensile stress at every part of the member. There's no neutral axis for this scenario. That means that this eccentric loading is causing stress. It's causing a deformation on every part of the member. So no part of the member is the original length L. There's deformation on every part of the member. Okay, so sometimes there will not be a neutral axis. But for our problem, yes, there is a neutral axis right there.